Okay, in example 6, it wants us to simplify the expression. And here they gave us some hints, okay? So watch for things like when you're adding and subtracting trig functions. Remember, you have to have common denominators in order to do them. And then if you see a Pythagorean identity in there, simplify it. Use them. They are very helpful to us. All right, so when we look at this, it says simplify the expression. So the first thing I see is that we are subtracting two fractions, and we know in order to subtract fractions we need a common denominator. And so remember, a common denominator, I could just multiply my two denominators to get a common denominator. So I'm going to multiply this fraction by the other fraction's denominator. So I'm going to multiply the denominator by 1 minus sine of x, and of course what you do to the bottom, you have to do to the top. Now for this first fraction then, I'm going to multiply it by the other fraction's denominator. So I have to multiply the denominator by cosine of x, and what you do to the bottom, you have to do to the top. Okay guys, it's no different, I'm going to come over here in a little thought bubble, than if I'd have said 2/3 minus 1/2. We could have said, oh, let's multiply both of these by 2 and got 4/6. Minus, and we can multiply both of these by the other one's denominator, the 3, and we'd have got 3/6, and then we can subtract them and get our answer, okay? It's no different than that, except we're dealing with trig functions instead of just numbers. Okay, so back to this problem. So when I do this first part here, I get cosine times cosine, which is cosine squared x. Then here, the second fraction, the numerator, I'm going to take this you know what? I'm going to back up for a minute here. I'm actually just going to write this out. How about that? So in the numerator, we have cosine of x times cosine of x. And then I have my minus sine of x times that 1 minus sine of x. And I put that 1 minus sine of x in parentheses because it goes together, okay? We multiplied it together. It came from the same denominator. It needs to be together. Okay, over our least common denominator, which was just the two denominators multiplied. So cosine of x times 1 minus sine of x. So now let's simplify this. We have cosine times cosine, which is cosine squared. And we're going to distribute this negative sine of x. So negative sine of x times 1 is negative sine of x. And negative sine of x times negative sine of x is positive sine squared of x. All over. And I'm not going to multiply the denominator until the very end because I'm hoping something will cancel. So for now, I'm just going to leave it as cosine of x times 1 minus sine of x. It's easier to me to multiply it at the end if I need to than to have to go back and common factor it out again if I needed to. Alright, so here we are, but I see a bunch of squares, so I'm wondering if there's some way I can put this together. So I notice I have a cosine squared of x plus sine squared of x. Well, cosine squared plus sine squared, that's a Pythagorean identity. We know that sine squared plus cosine squared equals 1. And so I can use that here. If I add those two together, that's just going to give me a 1. And then I still have this minus sine of x in the numerator over my common denominator. And so I can't do anything else in the numerator. I could distribute in the denominator, but I really don't want to because look at the numerator and the denominator together. That 1 minus sine of x is in both of them, and so therefore we can cancel it out. So on top everything canceled, so what are we going to put? We're going to put a 1 on top over what's on bottom? Cosine of x. But wait, 1 over cosine of x, that's a reciprocal identity. And so what was the reciprocal of cosine? Secant. So this whole thing is equal to secant of x.